This is a test review for Calculus with Applications, the unit on implicit differentiation and related rates. At the top of your test, you will be given these two formulas, so that will be typed on everyone's test. The first part here, just find the derivative, dy dx. So I'm going to do the power rule, 16x plus 2y dy dx equals 0. Then I have to isolate the dy dx. So I'm going to subtract 16x to the right. Divide both sides by 2y. And I can reduce the negative 16 and 2 to negative 8x over y. Number 2, we have a product rule here in the middle of negative x and y. Derivative of negative x is negative 1. Derivative of y is dy dx. So to start, I got my power rule. And I've got my product rule. I'm going to do y times negative 1 plus negative x dy dx. So that's just minus. Another power rule equals 0. And since both of these terms have a dy dx, I'm going to leave them on the left side. I'm going to subtract the 10x to the right. I'm going to add the y to the right. And as I do that now on the left, I'm going to factor out dy dx. Since both terms have that dy dx. And then our last step, is to divide both sides by negative 8 minus 8y. So that's the answer to number 2. I'm going to want this down here. Okay, so number 3, we've got the square root. So the square root, the derivative of the square root, you can change both of these to x to the 1/2 power, y to the 1/2 power, and then do the power rule and fix the negative exponent to a positive exponent. It's just a lot. So one of the derivatives that we've been encouraging you to memorize is the square root derivative. So the derivative of the square root is 1 over 2 root x. Plus, and then this one's going to be 1 over 2 root y dy dx. Derivative of 100 is 0. I'm going to subtract 1 over 2 root x to the right. To isolate dy dx, I'm going to multiply by 2 over root y. I'm sorry, 2 times root y. Sheesh. So I've got negative 1 times 2 root y over 2 root x. The 2's can divide. And there's our final answer. All right, number 4. We've got a product rule in the middle again. So here's our product rule between x squared and y. So individually taking the derivatives. So starting with the first term, got my power rule. And I've got my product rule, so y times 2x plus x squared times dy dx. Power rule again. Derivative of 1 is 0. A lot going on here. Okay, so these terms, I'm going to factor out the dy dx. These terms I'm going to subtract to the right-hand side. Last step, divide by this quantity. And there's our derivative. In number 5, I needed these formulas. So we just need cosine. On the left-hand side, I got 2y dy dx. We got a product rule here of x and cosine y. Derivative of x is 1. Derivative of cosine y is negative y prime, which is dy dx, sine y. So the right-hand side is cosine y times 1 plus negative, so really going to be subtraction, dy dx sine y times x. I want to leave this alone. I want to move this dy dx term to be over here on the right-hand side. And I'm going to write this as x sine y, so I don't need to keep writing those parentheses. So I added this term to the left. I forgot to write, oops. Okay, now we can factor out the dy dx on the left here. And our final answer will be cosine y divided by this quantity. Find the slope. So first we have to find the derivative, and then we will plug in the point because we're given an x and y. Product rule warning. Don't let these product rules trip you up. All right, derivative of x times y is y times 1 plus x times dy dx. Derivative of 16 is 0. No, you don't have to write that. So to get the dy dx by itself, I'm going to subtract y to the right. Divide by x. And then the slope is when I'm going to plug in these values, the x and the y, and we get 4. So at the point negative 2, 8, the slope is 4. Got another product rule here. Do my work over here. So that's negative x squared times y, which is negative 2x, dy dx. All right, starting with the power rule, 6x squared, product rule, negative x squared dy dx, y times negative 2x, power rule, derivative of a constant is 0, still 0. So this term and this term, I'm going to leave on the left and factor out a dy dx. So that's negative x squared plus 3y squared. I'm going to subtract 6x squared to the right, and I'm going to add the negative to the right. Then we have to divide. And plug in our point, and be careful with our arithmetic. Okay, so simplifying all that, if you want to use your calculator, you can. If you want to do the pieces, you can. We're going to get negative 36 over 23. So make sure, however you're simplifying that, you get negative 36 over 23. I need my sine rule now. Product rule again. Wow, we really want you to practice the product rule in this test review. Here's the product rule. X squared times y. Individually, each derivative. So when I go to put it together, we've got y times 2x plus x squared times dy dx plus sine y. So the derivative of sine is y prime cosine y. Derivative of 2 pi, 0. These terms both have a dy dx, so I'm going to factor that out. The same step, I'm going to subtract this term to the right. Divide. Substitute in our x and our y. Simplify. So in my numerator is negative 4 pi. 1 plus cosine of 2 pi is the point over here. The x value is 1. Negative 4 pi over 2 gives us a slope of negative 2 pi. Find the equation of the tangent line. Oh, and they're telling us what conic section. So this equation's an ellipse because we have adding between the x squared and y squared with different coefficients. The 5 and the 4 are different. Sometimes when you're adding in between, it would be a circle, but then those coefficients would be equal. So for this ellipse, first the derivative. So dy dx is negative 10x, subtract that over, divided by 8y. Let's reduce by 2. Finding the slope. We've got x and y. So that gives me negative 5 times negative 2 over 4 times 3. Negative 10/12, which is the same thing as negative 5/6. So the equation of my tangent line, I'm going to use point slope form. Well, here's my x1 and my y1, and my slope. If we want that, so that's point slope form. If we want that in slope intercept form, I would distribute the slope. And then add the constant over. And simplifying these values together, I would get y equals negative 5/6x plus 4/3. I made a mistake. Why I was pausing. Did you catch it? Negative times negative is positive. So this is really a positive slope. Fix that there, which would make this a positive 6/10, which would make this 14/3. And that would be positive. And this would be positive. Whoops. Okay, so to recap, negative times negative is a positive. That was my mistake. So I got a positive 5/6 slope. 5/6 times 2 is a positive 10/6. So when I add 3, there's the 14/3 for a y-intercept. So on the test, if it's multiple choice, the answer might be in point slope form like this, or the answer might be in slope intercept form like this. We wouldn't give you both on a multiple choice. They're both correct. So we'd pick one or the other. If it's free response, pay attention to the free response directions. If it just says write the equation on the line, you pick your favorite form. If it says point slope form, leave it like this. If it says slope intercept form, go to this. All right, let's repeat that again for a hyperbola. This is a hyperbola because of the subtraction between the terms. Found my derivative. So I'm going to subtract the 4x, divide by negative 10y. Negative divided by negative is positive. 4 and 10 can both reduce by 2. Plugging in my x and my y. I get negative 4/5. So y minus y1 equals slope x minus x1. Just for more practice, I could distribute the slope. Add my 1. So y equals negative 4/5 x. I'm going to make 1 5/5. Negative 8 plus 5 is negative 3/5. So those were all just plain find the derivative, use it for slopes, and so on. Now we've got related rates. A ladder leans against a wall. I'm going to draw a picture. 20-foot ladder. That's never changing. The length of the ladder is not going to change. How far from the wall might change, how high on the wall might change. So I'm going to give those variables. The bottom of the ladder, that's this part, slides horizontally at a rate. So dx dt, because everything's with time now, is 2 feet per second. How fast is the ladder sliding down? So dy dt, that's what we have to find when the top of the ladder is 12 feet. I can use Pythagorean theorem to find x. 0. So x squared equals 256. So x is 16. Setting up my equation, x squared plus y squared will always equal 20 squared. So again, the ladder is not changing, which is why that stays constant with a number of 20. How high on the wall is changing at a rate, how far from the wall is changing at a rate. So those both get variables. Finding my derivative. Everything gets a dt. Plug in what I know. X is 16. dx dt is 2. Y is 12. Have to calculate dy dt. So we've got 2 times 16 times 2 is 64. And as I write that, I'm going to subtract that to the right. 2 times 12 is 24. We'll divide. So dy dt is negative 2.6 repeating, which as a fraction is negative 8/3 feet per second. Don't forget your labels. Here's that rate for this problem, feet per second. We're going to skip number 12. You can skip that problem. In 13, the way the problem's typed is we have different units, and it's just extra. We're not going to do different units. So on the unit test, everything will be the same units in every problem. If the rate is feet per minute, the radius will be given to you in feet. So you can update, well, first off, not the diameter, just change it to radius and it's feet. So gas is being pumped into a spherical balloon. Here is the volume of a sphere. Let's find the derivative. So dv dt is the power rule 4 pi r squared dr dt. So what do we have? I have r. This is cubed, so this is the volume rate. 5 equals 4 pi 3/4 squared dr dt. Find the rate. So I'm finding, that's my question, the rate, the radius is changing. So the dr dt is my variable. That makes sense. That's a good sanity check. Now we have to calculate. Squaring a fraction, I square my numerator, square my denominator. I can combine this. So 4 times 9/16 is 9/4. So I've got 5 equals 9/4 pi dr dt. And I actually I'm going to write this as 9 pi over 4, because then to isolate my variable, if I multiply by the reciprocal, this divides to 1, this divides to 1. I'm left with my dr dt. So we got 20 over 9 pi feet per, what is this one? Minute. Feet per minute. And the radius is a linear piece. It's not area. Area would be squared. It's not volume. Volume would be cubed. A radius is just a segment. So we just have plain feet per minute. All right. The area of an equilateral triangle is decreasing. So the area rate is a -4 centimeters squared per minute. Find the rate at which the length side is changing when the area is 200. I don't have a side length, and I want to find this rate of the side. So let's find the derivative. dA dt is power rule . I can reduce the 2 and the 4. And let's see what we got. I have the rate of the area is changing. I want to find the rate that the side is changing, but I need a side length. And the only thing I'm given is area. So if I plug area into the original area formula, then my side is my variable. So let's find what side is. I got 800 over root 3 is the side squared. We're going to square root both sides. So let's get that decimal. So first, let's find 800 divided by the square root of 3. Square root that. So the side length is 21.5. Okay, so I'm going to multiply these together and divide that to the left side. Let's see what we get. We've got -4 divided by that answer is -0.215 centimeters per minute. And again, because it's the side, it's similar to a radius. The side length is just a segment. It's measured in units, not units squared, not units cubed. All right, and number 15, a stone is dropped into a lake, causing circular waves with a radius that is increasing at a rate of 0.5 meters per second. So, oops. The rate of the radius is 0.5. At what rate is the area? So area of a circle is pi r squared when the radius is 4. All right, so our derivative over time, we're given r, we're given dr dt, and we need to find the rate of the area. So 2 times 4 is 8. 8 times 1/2 is 4. Keep my pi. And since now it's rate of area, area is units squared per second. So meters squared per second. There's one more review page. I'm not going to do all of them. I'm just going to do the ones that are slightly different. Identify the graph. So your choices are circle, ellipse, hyperbola, and parabola. And we focus on these conic sections during this unit because they are equations written with x and y on the same side. They're implicit equations. We can't, oh, you know what? And there's also line, sorry. That these conic sections are written with x and y on the same side of the equation. We don't isolate the y. So the reason I added in line, I got a glimpse of D here. There's no squareds. There's no other exponents. This one's linear. You can say line, you can write linear. But the others, they're all x squareds and y squareds. So the difference, we have subtraction, that's a hyperbola. When we have addition, it's either circle or ellipse. So when the coefficients are the same, that's a circle, since x squared plus y squared equals r squared. When the coefficients are different, that's an ellipse. It's kind of like an egg shape. They're called conic sections because they're from slicing a cone. And just to give you a visual, if you slice the cone directly parallel to the base, you get a circle. If you slice it on an angle, you get the ellipse. If you slice parallel to one of the edges, you get the parabola. And if you slice perpendicular to the base, you get this hyperbola, which is these two pieces together. No, those were way back in geometry, but that's an example of what they look like. I'm going to skip number 2. It's just more find the derivatives. I will do number 3. This one's a little tricky with the way it's worded. The perimeter of a rectangle is 24 inches. The length is increasing, so the dl dt is 3. The width is increasing, so that's dw dt. How fast is the area increasing when the length is 8 inches? Okay, so a lot going on here. First off, they give me perimeter, but we're talking about area. I have the length. Well, let's find the width. I know that perimeter equals 2 length plus 2 widths. So 24 equals 16 plus 2w. Subtract the 16. Running out of space. So the width is 4. And now when I have area over here, I can't go straight to the derivative. It's a product rule. I have length times width. The individual derivatives. And the product rule says width times dl dt plus length times dw dt. Can't forget about my area rate. We want to know how fast the area, so that's my variable. Width is 4. The rate of the length is 3. Length is 8. The rate of the width is 2. So we get 28 inches squared per second for the rate of the area.